This is a video on an application of vectors. The question states, a plane flying at a constant ground speed of 500 miles per hour due north encounters a 40 mile per hour wind from the southwest. Find the airspeed and compass direction that will allow the plane to maintain its ground speed and northerly direction. So let's start by sketching a diagram that uses vectors to represent the airplane and the wind. So here's what we have. The airplane wants to fly due north at 500. So I sketch a vector that goes in the positive y direction of magnitude 500. The wind is coming from the southwest at 40 miles per hour. So that means that the vector will have magnitude 40 and its angle from the negative x-axis will be pi over 4. In other words, the angle from the positive x-axis will be 3 pi over 4. So for this wind vector, we can write down its components by saying that the wind, W, is 40, which is its magnitude, times the cosine of the angle, or the cosine of 3 pi over 4, I, plus 40 times the sine of 3 pi over 4, J. The cosine of 3 pi over 4 is negative root 2 over 2, and 40 times negative root 2 over 2 is negative 20 times root 2 over 2. So I get negative 20 root 2 over 2i, and then 40 sine 3 pi over 4 is 20 root 2 over 2, so I get plus 20 root 2 over 2j. The vector in the positive y direction at magnitude 500 is just 500j. So we could say that the vector we want, which is this vector in the first quadrant, plus the wind vector, should be our final vector, which is 500j. Or in other words, v plus w is equal to p, where v is our unknown vector, w is the wind, and p is the plane. We can subtract and get v equals p minus w and substitute in. So we get that v is 500j minus negative 20 root 2i plus 20 root 2j. We can combine the j components and get 20 root 2i plus 500 minus 20 root 2j. So now we can find our angle by using the formula that the angle is the arctangent of y over x, which is the arctangent of 500 minus 20 root 2 over 20 root 2. And I put that in my calculator, and I got that my theta, or my angle, is about 1.51 radians. And by the way, 1.51 radians is about 86.5 degrees. And that kind of matches our picture. Now let's find the speed of the airplane. So that means that we're going to take the magnitude of this vector, which is the square root of the sum of the squares. So I find that the speed is the square root of 20 root 2 squared plus the quantity 500 minus 20 root 2 squared. And I put that in my calculator, and I got that the speed is about 472.56 miles per hour. So I can conclude, in order to maintain a ground speed in the northerly direction at 500 miles per hour, the airplane needs to travel with an airspeed of 472.56 miles per hour and have a direction of about 1.51 radians from the x-axis. And I'm done with the problem.